This is Robert, and this is the third video in creating a list object. When we left off, we noticed that this object was pretty well encapsulated except for this line right here on line 20. It would be nice if we could set the item count to 0 and have it be encapsulated, and it would also be nice if it happened automatically. C++ uses a constructor for that. And so we can move this statement into our constructor. Constructors don't have return types, but they still have to have a prototype. And the way we create a constructor is just by using the object name or the struct or class name. And okay, so then we would just say list, and so there's our constructor prototype. So I'm just going to say constructor right here. And then when we want to implement the constructor, we can just create it like any other function. The only difference is that it doesn't have a return type. So I just say that the list constructor is inside of the list object, and then there will be no arguments for this particular constructor. Since there are no arguments, that makes it a default constructor, and so we can only have one default constructor. So the default constructor does not have any arguments. The only thing I wanted to do is to set item count equal to 0. And remember that I can access every item inside of the object directly. So I don't have to use groceries.itemCount. I can just use item count directly. So I don't need this line anymore on line 25. Okay, so our item count will be set to 0 automatically. Let's go ahead and put a breakpoint right here, and we'll be able to see that our constructor will run automatically as soon as groceries is created. So I have a breakpoint right there. I'm just going to start up the program. And you can see that it stopped. I have a breakpoint right on line 23. So what I'm going to do is I'm going to step into that, and we can see that the flow of execution will jump to the constructor. And because the reason is because when we instantiated groceries, or when we created that variable, that's when the constructor will automatically be executed. And we can see that we're executing inside of the constructor now. And so if we step over it, item count will be set to 0. So anytime an object is instantiated, the constructor for that object automatically runs. Okay, so now we've encapsulated our item count being set to 0. We've encapsulated that inside of the object. Okay, if we look over our code file right now, we only have one code file, and we can see that this is a constructor, this is a struct definition, here are some libraries, and then we have our main function. And then if we scroll down, the other methods for our list object are kind of intertwined with the rest of the code. And so let's say I work for a company, and my task has been to create a list object. And when I'm done with it, I need to share it with the rest of the code writers in my company. Well, if my main function is inside of the same code file as the rest of my functions, then I'm not going to be able to share my list with the other workers in my company. So what I need to do is I need to move some of these items into a header file and some other items into what's called an implementation file. So let me take a break, and when I come back, we will have a new project set up that uses multiple files. Okay, so I've separated out my project into 3 separate files. I have the list implementation.hpp file, and that's the header file. Then I have the list implementation file, and then I have my main function file. The list implementation header should have all of the code in it that is not executable. So I have some constants listed, I have a library listed, and then I have my class definition. Notice that I changed the word struct to class, and then I also added the word public. That's a label for public, and we'll discuss why I needed to have that keyword public right there. And since I changed this to class, the default behavior is to make these things private. So unless I say public, these are going to be private. And we'll discuss why we would want to do that in the fourth video. Okay, in order to make this code available to my other source code files, I have to include the header file just like I do any other library. But the difference between including a header file and a library is that with libraries we use the angled brackets. I've included list implementation.hpp in both my implementation file and in my main function file. But you can see that I'm using double quotes right there instead of angled brackets. If I use double quotes around my header file, then that means it should look inside of the working directory, the directory that contains my source code files, rather than in the I guess the code repository for all the libraries that come along with your IDE. Okay. So in order to include a file in both the implementation and main, I had to include them both. If I don't include the header file, then you can see that I'm going to get lots of errors. And so basically, if I don't include the header file, then C++ doesn't know what a list is. And I also put my IOStream library in the header file so it doesn't know what cout is. But as soon as I put the header file back, now it can know about IOStream and it can know about my list definition. I have to do that in both files though. So it's going to try to include list implementation.hpp twice. That could cause some name overlap. And so the way C++ solves this problem of including a file twice is it uses these preprocessor directives right here. So the first one is if ndef, and that stands for if not defined. Well, if this thing right here is not defined, then the first thing we're going to do is define it. And then we're going to compile all the rest of this code until we get down to end if. That's the first time that the compiler sees the code. Maybe it compiled implementation first, and so it sees this #include statement first inside of implementation. Or perhaps the compiler decides to compile main.cpp first and it includes it in main first. Either way, it's going to see and compile the header file from one of those other source code files. Then when it's time to compile the other one that it hasn't gotten to yet, it's going to see this code again, and it's going to say, if not defined. Well, the second time it sees this code, it's actually going to say, yes, implementation_hpp is defined. And so what it's going to do is it's going to skip from this directive down to this directive. And so basically what it does is it skips over everything in between. And that's how C++ allows us to include a single header file inside of multiple source code files. The last thing I would like to point out about our multi-file project here is that the code can actually be much more manageable this way, and I'm also able to share my code much more easily. If a coworker would like to have my list implementation All I have to do is give them the list implementation header file and the implementation file, and then they can use the code that I have written, and they can include it in any project they have. And the reason for that is because we can see that all of the information for the list is included in the header file. And then in my implementation file, only the methods involved with the list implementation are included here. So I can just give them this file and there won't be any other code involved. We can see that we have a couple of constructors here, and then we have a destructor, and then we have a member function called print the list, and then we have add an item, which is also a member function. And then if we take a look at my main function, notice how short this code file is. It's much more manageable, so we can just switch back and forth depending on what we want to do with our code. So, and main can be replaced with any other main program, and any main program can then have access to the list implementation. Let's take a look at how we can add multiple files to a Visual Studio project. Okay, if you are using Visual Studio to write your code, it's a very similar setup to Xcode, except that Visual Studio gives you predefined folders in your Solution Explorer. We can see that we have a header files folder, and then we have a source files folder. Okay, so all of the source code files should go in source files, including main and list implementation, but the header file should go in the header files folder. In this project, I've called the header file list.h. If we want to add something to the header files folder, all we have to do is right-click on it and then add. So we can either select a new item or an existing item to add to the header files. Very similar to the way we can add something to the source files folder. Okay, so in this project, I have the word struct right here. And on the last video, I showed you that we changed that to class. Well, the difference between a struct and a class is just in the permissions that are the default. A struct has public permissions as the default. So, for example, if item count is considered public because this is a struct, which means that I could go to my main source code file, and if I wanted to, I could just change item count inside of groceries if I wanted to. So, for example, I could say groceries dot item count equals 10 or something like that, and the compiler allows me to do it. This would be a mistake though, of course, so we want to guard against that, and we want to make sure that item count can't be changed unless we are adding an item. So what we can do is we can change the permissions in our list struct right here. If I want something to be private, I can use the private keyword. And so now everything following this label is now considered private and can't be accessed outside of the list implementation. Since we have these member functions right here, then I can access private members. So if we take a look at our list implementation, we don't see any errors here. Item count is still accessible because this is a member function. But if we switch to main, we should see an error here if we try to change item count. Notice that we also have add an item off limits and also print the list. So we definitely want this to be accessible and this, but we don't want this to be accessible. We only want to be able to change the item count inside of add an item. So let's switch back to our header file, and I want these two items to be private, but I want these two member functions to be public, accessible to code that is not part of the implementation. So now I have public right here, and so if we switch back to main, we can see that add an item and print the list is accessible, but item count is not. This is a mistake anyway, so I should just get rid of it. And so that's why we have public and private labels for our classes and our structs. This is left over from the previous video also. So we fixed that by creating a constructor in the last video. But let's take one more look at the difference between struct and class. I can go ahead and interchange struct and class now because I have a label, a private label for everything that I want to be private, and I have a public label for everything I want to be public. So I made it explicit what I want the permissions to be. So it doesn't matter either way now if I say struct or class. It's going to behave exactly the same way because I was explicit about the permissions here. If I say class, then everything inside of the class is considered private automatically. So I can go ahead and get rid of that label. But then if I want anything to be public, I need to go ahead and use this label right there because everything inside of a class will be private by default. So if I get rid of that public label, now these items are considered private. Okay, so then if I use a struct, it's the opposite. Everything in the class is considered public. So these items are now default public. So what I would want to do is I would want to say private. And now I have these listed as private for the permissions. So the only difference between a struct and a class is that a struct is public by default and a class is private by default.